Hello everyone, I'm Amir Hossein. Welcome to another training video about the RTTOV model. If you remember, in the previous video we talked about how to run RTTOV model using atmospheric data retrieved from ERA5 outputs. In this video we talk about running RTTOV model using atmospheric data retrieved from WRF model output. So if you remember, we have a RTTOV-Py module. We have a Python module called RTTOV-Py. This is the repository to get this Python module. And after cloning this repository and navigating to the directory, you have two distinct directories. One directory for running RTTOV model using ERA5 data, and the other directory is for running RTTOV model using WRF data. So we navigate to this directory, WRF data, and you can see the contents of this directory are quite similar to the contents of the ERA5 directory. It has a name list and also another YAML file which lists the satellite names with their indexes. These are the satellite name list and their indexes. So for example, if you want to simulate NOAA number 10, you should put number 11 as the index of this satellite. And there is name list. I open this name list, and inside this name list we have several different variables that they are almost the same variables in the ERA5 directory, but let's review them again. The first variable is the directory, the installation directory for the RTTOV model. So just let me list the content of this directory. You can see the contents of the RTTOV model. And the second variable is the coefficient file of the satellite that you are going to simulate. Let's say we want to simulate MODIS AQUA image. So for the first we should find the index of this satellite. The index of this satellite would be number 1, AQUA. So the index is number 1. I open name list, and here in the satellite information I put number 1 as the AQUA sensor. And for this coefficient file, let me go to the directory that contains this coefficient file, and I search for MODIS, because AQUA is a sensor on the MODIS satellite. So I just search anything with which MODIS is in it, which includes MODIS. So here we have 4 coefficients. For the AQUA sensor, this coefficient is the coefficient for AQUA sensor, MODIS AQUA sensor. So here I copy the path to this coefficient file, and I go back to the name list, and here I paste the path here. So now this variable has been set for the coefficient file of the MODIS AQUA sensor. Okay, the next variable is the WRF file path. This is the WRF file output, the WRF output that you are going to use to retrieve the atmospheric data, the required atmospheric data to run the RTTOV model. Just let me show you what is inside this WRF model output. And yeah, this is the domain. Let me make it bigger. This is the domain. You can see that here is the Mediterranean Sea, Red Sea, Persian Gulf, and Caspian Sea. And the best approach is to let me get back to the name list. To the name list, you can see some other variables, but just let me show you that one of the important variables that you need to set is the satellite position. So if you want to set a user-defined position for the satellite, you should make this variable enabled and make this directive enabled and set a latitude and longitude for your satellite. Here the best approach is to set the satellite in the middle of your domain. So just let me see how is the domain, how is the range of the latitude and longitude in this domain. Let me open latitude here, and for the latitudes the range is between 24 to 41 degrees. So let me just put here something in between. Let's say 30 60. The sum of it would be 60. 33 would be the middle, almost in the middle. So I put here 33 as a middle latitude, and let me open longitude. The range of longitudes are between 31 to 52, and the average of this value would be 44, 83, 45, about 44 or 43. Let me put here 43. Okay, and so with these latitudes and longitudes, we have the satellite, the position of the satellite almost in the center of our WRF domain. I close it and I get back here, and this is the time directive, time of simulation, and time of simulation of course must be included in your WRF model output. Let me open it again, and let me open the metadata, and if you check the metadata, the start date is 2022 5/15. So let me set a simulation date of 2022. Let me keep it on top. Get back here, 2022, and the month would be 5 here, 5, and the day would be 15, and the hour I set 12 for the hour. This is a time that is included in your WRF model output in this file. That's we want to use it and simulate AQUA sensor image using RTTOV model. Okay, these are some arbitrary variables. You can set them as you like. These variables are used to name your directories. Directory suffix, appendix to the WRF file name, no need to be changed. So just, you don't need to change it. So just we leave it as it is. And this directive is for WRF, for the WRF chem model, and for the dust simulation. We will talk about it in another video. So we leave it for now, and this is the satellite information, satellite name index, which we have already changed it to number 1, which will be the AQUA sensor on the MODIS satellite. And the satellite index, I don't want to change it. I'm not sure how many channels are there in the MODIS, but let's say we want to simulate the first 3 channels. And about the names of these channels, let me change just a little change. Red Chan green chan and blue chan. I just change it to show that you can easily change these values. And we have already set the user-defined position here, the location of satellite. And for now we don't want to make any post-processing, so I just made it false. I just disabled this directive, this block. So everything seems to be ready. I just save it, and now you can run it, but you must be sure that all the required Python modules are available in your environment. If I run it as in this environment, it shows some warning that some Python module is not available. I activate my Conda environment, and now I can run it again. Directory has been created, and now data in each grid point of the WRF data that we have specified in the name list have been read, and the profile of atmospheric data in the format that RTTOV needs are extracted in separate files that you can get access in this directory. Just let me show you. These are the files that for each grid point within the WRF file has been extracted from the WRF file and created in the same format that RTTOV model needs. For example, let me open one of them. Let me open the last one. The last one shows that we have 3,844 grid points within the WRF file. I open it, and you can see that here on different pressure levels we have different temperature profiles, and with water vapor they are automatically extracted from the WRF model output. And here are some surface variables: 2 meter temperature, 2 meter humidity, and so on, wind speed, and so on. And this is for the one grid point, and so we have the all data required for each grid point. Now we have also another file here. This is a shell script that you can use to that you can run in the next step. After you run this shell script, it actually reads the data which are stored, the profile data which are stored in this directory, and runs the RTTOV model for each data file, for each profile. So just run it. Before that, don't forget to specify the architecture G4 Now it is running RTTOV model for each profile data that we have already created in the previous step. There are about 3,600 profile data, so it takes maybe 1 or 2 minutes. We just wait for it to be finished. And after that, I will show you that you can make a netcdf file from these RTTOV outputs, because you know the RTTOV outputs, they are as the format of text file, so you can convert all of these text file to one single netcdf data, and each single netcdf data is for a variable, a specific variable. Variables are brightness, temperature, radiances, and so on. So the running RTTOV model for each profile data has been finished. Now you have another directory here. Let me go to the outputs, and here you see that RTTOV model output for each profile data or for each WRF grid point have been generated. I just open one of them and navigate to the bottom of the file, and here you can find calculated brightness, temperature, radiances, and so on. Some primary radiation variables. Okay, and now that we have run RTTOV model for each grid point in the WRF data, we can also make netcdf file. Just open main list and go to the post-processing. I enable it true, and I also enable plots. I enable all of them true, and I'm not sure if this setting, this configuration of red, green, and blue will produce something fruitful, but let me correct it. Blue channel here, this is the blue channel, green channel, and red channel. This is just a calculation of 3 different channels of this RGB image. You can change it, but no problem. I just want to show you how to do that. So for the post-processing, you have seen that I enabled all of them for netcdf. It makes this variable makes netcdf, the other variables makes plots or images for the netcdfs, and this is a variable that is used for making RGB images. I save it and I run it again. Plotting red channel, plotting green channel, blue channel, red channel for radiance, brightness, temperature, and other variables. Now I have another directory here, output, post-processing, and you can see that we have netcdf data. For example, for the brightness, temperature, this is the netcdf data, and so I repeat that this netcdf data has been generated or has been made by using the RTTOV output. This netcdf data has been used by the RTTOV outputs that were generated in this directory. Okay, we have 3,844 profiles. So this netcdf data, it actually has 3,844 grid points here for brightness, temperature. This is for brightness, temperature, for channel red, this is for channel green, and this is for channel blue. So what we did here was actually simulating a satellite image, actually the MODIS AQUA satellite image, using atmospheric data from WRF model output. And we ran RTTOV model to simulate such an image. And also output, and also let me open the plots of some images. Brightness, temperature, blue. This is also the image. For the, you can see that it is for blue channel, green channel, and red channel. There are very small changes, very subtle changes that you may notice here. This is for emissivity, the other variable. This is for radiances. Overcast radiances. There are four or five main variables that you can simulate by using satellite, by using RTTOV model. So yeah, that was it. In the next video I will probably talk about how to simulate satellite image using WRF model, output, which is actually affected by the aerosols, especially dust outputs or dust concentrations.